It is my honor to introduce our wonderful speaker today, Luis, who will be teaching you all how to think like an engineer. He's had years of experience at some wonderful bank companies in the Bay Area and has done some incredible research in the Philippines as well. And so he'll be showing you how to use AI tools in the prototyping process. And it started off with his idea of building a stitch counting app while his son was knitting. So, yes,
you're spoiling the.
Oh no! Well, a little sneak peek, I suppose. So, yeah, let's give him a wonderful, warm round of applause.
Hi everyone, I'm Luis Sarmenta, and Professor Kai was kind enough to invite me, and it sounded exciting having all you here. So I thought with all this vibe coding, AI coding, it's very exciting. I'll tell you the story. But before that, quick background on me. I'll be here. I'm planning to be here. During this, every Friday. I'd like to learn as well from you all, and I'm also happy to share. So since I'm going to be here, might as well spend a little time just quickly introducing myself. So my name is Luis Sarmenta. One thing, I've been Jesuit trained since high school. So I kind of feel a connection here in the Philippines at Ateneo de Manila University. And actually, in college at Ateneo, back in the 90s, I wrote an antivirus for fun. It was like, I want to do assembly language programming. What can I do? And it ended up being used all over the Philippines. It was actually second to McAfee in terms of number of users back then. And that was the point where I kind of felt like, this might actually be like a calling, like a mission. It's like I can do something, I feel like maybe I should do something. I'm called to do something good with what I've been given, and also to empower others to do so. So maybe I got that from Spider-Man. But anyway, I blame the Jesuits. But so after college, I did my PhD at MIT. I did my PhD thesis on what I call volunteer computing. This is about enabling people to volunteer their idle PCs at home to make a big supercomputer. And I did this because it's applicable in the Philippines. We didn't have money to build computers, but everybody had computers at home, and you could do parallel processing that way. And I codenamed it Bayanihan, which is this Filipino tradition where it's basically like cooperations, community cooperation, where people would literally help somebody move by carrying their house. And this is a real thing. And I'm partly here because I enjoy teaching and advising students. So after MIT, I went back home. I was a professor in Ateneo. And one of the things I did there was I started up a lab there where the students could do projects, and then they could sell their apps and services. This was before iPhone, so it was more like SMS, MMS services with the mobile operator and make money. And we actually made money so much money we had to it became net profitable, so we had to spin out of the university because the university is supposed to be not for profit. And that was really a fun experience for me. After Ateneo, I taught there for a few years. I went back to MIT as a research scientist, and I taught a class there on the side on using mobile phones for developing. And we had another kind of project-based class where we had the students working with different organizations around the world doing projects. And another reason I'm here because I found out that SCU is doing this Frugal Innovation Hub, and it's very similar to what we were doing. So I'm really interested in that as well, and it's really cool that you guys are doing that. And after 2009, I felt like I had to support my family. So I moved here to we all moved here to the Bay Area. And I worked in big tech for 15 years. I started at Nokia, Microsoft. I was at Meta for many years, and then most recently at Google. And I've done a whole bunch of stuff from mobile to educational stuff. I worked in PowerPoint, internationalization. My PhD on volunteer computing, I was actually useful even at Meta because can translate the same ideas to crowdsourcing and human computing and to cloud as well. So for those of you doing your PhDs, I think pick a topic that you can use for good, like even after your PhD. That would be cool. So now I'm actually taking a break from big tech because AI is so exciting right now. There's so many things going on. I want to actually explore. And my son just graduated, so I'm not paying for tuition anymore. So I feel like now I think this is a good time to kind of explore new ideas, especially with like AI, where you can just kind of have an idea and then go. Right? So this brings me to and because there's so many new possibilities now, I'm actually here also to learn from you all. I'm very eager to do that as well. So this brings me to why why give this talk, right? So I heard about this, and at the same time, so here's my son Joseph. Okay, so he's not a CS major. Okay, and I told him you should really try this vibe coding thing. And he said okay. He's actually into knitting. Like we went to the Philippines and he was kind of bored on the plane, so he was like knitting this sock. He's like, okay, well, I'll try. Like I want to make a pattern tracking it. And so I said, okay, just try it. So he said, okay, one prompt, right? So and then with one prompt, 5 minutes later, he had this app. Right? And he's like, oh, this actually kind of works. And then he actually said, I'm glad I didn't waste 4 years of my life. And I was like, So, but then he said, like, okay, let's. It's not quite right. Let's try to get AI to fix it. And it took him days, and these are his actual prompts, right? Like AI started breaking the stuff that it was. So I was like, okay, right? I still have a job. So a job as a father, I still have something to teach, right? And as an engineer, I think a lot of maybe for computer science majors here, you might be wondering. I believe that there's still jobs for us. Maybe it's not so much just doing the actual coding, but actually thinking about stuff. And this is why I wanted to talk about this, right? And you guys probably know about this already. I think. For those of you who are not engineers, then I hope you learned something. For those of you who are engineers, then I hope to kind of encourage you. It's still very valuable. And so it's valuable even with AI because one, it helps you understand what AI is doing. AI is so powerful now. It's actually I'm amazed. But you run it, and then it comes up with all this garbled stuff, and if you don't know what's going on, right? You don't know what's going on, right? So it actually can help you prompt AI more effectively, and this could actually not only get things right sooner with fewer bugs, but also faster and with less cost, right? So these tokens are expensive, and like what my son was doing, if you want to make changes and improvements, it's nice to be able to talk the language of AI in a way, right? So even if you're not an engineer yourself, if you can at least kind of think like an engineer, it'll help you work with the AI. The other thing with that is once you're thinking in terms of, and I'll talk with what this means exactly, but once you kind of think like an engineer and like the AI, then it makes it easier for you to build stuff that can run on different platforms like web, iPhone, Android, and even expand to other use cases. So a big thing that engineers do is have reusable components, like modules, right? So so you can build stuff that are reusable. And I think thinking like an engineer, at least my bias is, it helps with life in general too, when you think of other things. Okay, and so a bit of a disclaimer here. First, that's an AI generated picture modification of me, but I use the AI, for pictures and stuff. But actually, most of this, the vast majority of this slides is not AI. I had tried to do it with AI, but it wasn't quite right. So I had to spend a lot of time manually tweaking it, which is kind of symbolic in a way. But the real disclaimer actually is that I want to be clear that it's not my goal today to teach a specific techniques for using AI. I'm going to show you some technique, but I'm pretty sure it's probably not the best way. And I actually think you guys, some of you would actually know better, and I'm happy to learn from you as well. So I'm just going to teach something that worked for me. I'm still learning. So don't take whatever I do as the gold standard. but what I actually want to talk about today is how to think, right? So what I want to, what I hope to share is a mindset that I think would be useful, even regardless of whether you use AI or whatever tools AI tools you use. And also, I'd like to share, I guess, this feeling of like that what I feel like as an engineer. Like I see systems everywhere, and I feel like there's a certain kind of beauty in that, like, oh, I see something and it's like, oh, I know how things are connected. And it's just naturally how I think, and I'd like to share that. And for those of you who are engineers, you probably feel the same way. And for those of you who are not, then I hope, it can kind of make you feel the same way. So what is engineer thinking? Thinking like an engineer, okay? So think in one word, it's systems. And another word, it's Legos, okay? So what about Legos? So what do I mean by this? Well, to be specific, like first thing is be specific. Okay, so engineers, one of the things, and this helps with AI, is engineers like to think of the spec. And by spec, I don't just mean like specifications, which is what it literally means, but like just be specific in everything, when you're trying to think about stuff, right? So describe things clearly in an orderly way, identify ambiguity, and if you think about Legos, like if the instructions, they don't have any words in them, but you can understand them, right? Because they make it clear, right? You know what piece you're supposed to be using, right? The second thing is, think about breaking things down, decompose things, right? Again, with Legos, like everything, can be broken in parts, and this is very important when you're trying to describe a problem, right? Or trying to understand the system. And so you make lists, and then you make sub-lists. You look at like the steps of a process, and then there's a sub-step of that step, right? And parts, what are the subparts? And of course, like as you break down, you also build up, right? And I think this is another thing that engineers do, which is that they build bigger parts by putting together smaller parts, right? So you can kind of see here with the Legos, even the obviously it's really small parts, but as you build them up, like there are certain parts pulled together in kind of related kind of components, right? So there's the building blocks, the components, and then you put them in structures, and then the modules are like reusable structures, and then the whole thing is a system. And you can have systems then become building blocks for other systems that go bigger and bigger. And really, that's the key. So one thing to take away, be specific, break down, and compose. And I think the breaking down, decomposition, and composition, I think is a key thing to thinking like an engineer. And this is what I'm saying. Like, I see everything in terms of like systems and components, right? So, and if you think about it, right? So if you think about computing, we start from electrons to, transistors, gates, chips, servers, data centers, and then the whole world, basically. Self-driving cars, right? Satellites. But it's not just that. Even life is like that as well, right? So from cells, from DNA to cells, to like organs, organisms, and to whole ecosystems. So in computing or in engineering, that's kind of what you're looking for. Like when you see a system or a problem, or even when you're building a solution for a problem, you ask like, what are the components of this system or problem, right? And then you ask like, what are the inputs? Like generally, like this is another thing that I want you to take away from this is that everything is generally something like has an input, has an output, and it has behavior, right? So, and I'm sorry, I'm not really going to be talking about games. There's like kind of switch topics because I thought somebody else was going to talk about games last week. I'll talk about a possible game you can do as a fun exercise later. But when you think about games or even like self-driving cars, right? Everything is always, you're always getting inputs, right? And then you're thinking about, or you're computing what you're going to do next, and then that's your output. Like which you're getting inputs, what you're seeing, and then which direction do you go in? Or you have this object and it bumps into another object, and like what direction do they go in after they bump into each other, right? So it's always like inputs, outputs, and then the behavior depending on that input and output. And also like how these things are connected, right? So in a system, you have, and also how things are composed. So in a component, inside that component, there's usually other components, and these components are connected to each other, and those components have components as well, and then so on and so forth, right? So this is actually a core part of like thinking like an engineer. And I'll come back to this. This is very key. I'll come back to this. But another part of thinking about like an engineer, more applied to what we were talking about today, which is like how do you kind of solve problems, build apps, vibe code. Well, a key thing is engineers would want to spec out what you want to do. Okay, and this is the thing. If you work in industry, there's a lot of processes where you write down a document. I'm going to call it a spec, just because I want to stay in this theme of like be specific. But it's usually like design documents of different types, basically. And this helps you kind of know what you're doing and helps other people coordinate with you as well to build the same thing. And so in the theme of being specific, like what you do if you want to build something is you specify, I'm going to break this down, okay? First why, okay? Then what, and then how, right? And this is actually how you write design documents in industry. So by why, well, actually, before I get to that, the how, which is like how you code it, okay? This is what AI will take care of, okay? So this is the part where you spend 4 years or used to spend 4 years of your life trying to like, how do you like write the text that will make the computer do this? AI will now take care of this, right? But there's still a lot to do before you get there. You have to still think about the why and the what, okay? And the why is basically what are your motivations and what are your goals, right? And if you break this down, the motivations, usually you can express that in terms of the user journey, okay? And then the pain points of users in that journey. Okay, and then given that, what do you want to solve for them, right? And then you have to prioritize because you can't do everything all at once, right? And then you come up with this minimum viable product, right? So this is kind of the why part and the what are we aiming for part, right? So this part you have to do. So AI can't tell you this because AI can't tell you what you want, or at least it shouldn't tell you what you want. And it can't tell you why you want it, right? If you start letting AI tell you that, then I'd be a little worried. So I think there's actually an opportunity here for another talk, how to think like a product manager, because this is what product managers basically do. But today I'm talking about how to think like an engineer, and this part is mainly what engineers would do, right? And this is what are we going to build, okay? And we can break this down as like features, components, or the architecture, and then the scenarios. You have to think about like what if, right? So features would be like okay, we have a goal. How are we gonna solve that? Okay, well let's define. If you enable the user to be able to give them a product that gives them this experience, then it helps with their pain points, right? Now, of course, as we say, you have to prioritize, and you can only build one thing at a time. So, as an engineer, you have to scope for a particular version, okay? And it's okay because you start small and you build up, right? So you start with a simpler version, and then you iterate until you build the whole thing. Right? So this middle part will actually repeat with different versions that grow bigger and bigger. Okay. Now the component thinking that I was talking about earlier. This is the design. This is the architectural or the system design, where basically, as I said, you look at the components, you look at the inputs and outputs, the data that will be moving in and out, the information, and the behaviors, and how these are connected to other components, and as well as internally. And then it doesn't end there. Now you have to think about what ifs, right? So what if people don't use it correctly, or what if something goes wrong, right? So this is where testing comes in, right? So this whole thing is what engineers do, and you do this all the time if you're especially in a software company, but also in other engineering companies. So this part actually. AI can do a lot of this already, and it's doing it more and more. In fact, since I started making this talk, I started realizing, actually, I can have the AI do this already for me. But But I think it's still much better if you can do it as well yourself, right? So because somebody has to understand the AI, and AI doesn't always get it right. And you have to be able to guide it and understand it. Okay, so just to give you an idea, this is kind of like the picture of the cycle here. Okay, so this you as an engineer, okay, you'll be probably working with a product manager. Okay, and usually the process is something like you produce this PRD, a product requirements document, and you say, okay, who are our users? Why are we doing this? What are the pain points? And what are our goals and priorities, right? So actually, this is the other thing. Product managers now can just vibe code, and it actually is pretty helpful. Okay, so but to turn that into an actual product, you still need engineering. Okay, so engineering gives a little bit more details into actually how this is going to be done. And again, you ask the why, what, and how. Okay, and then you have AI coded for you. Then it produces an app. Then you kind of cycle, iterate, improve it, fix it. Okay, and so this is the bulk of the engineers' work, basically. So what I'll be talking about today. Okay, so back to knitting. Okay, so if you're thinking about the knitting problem, okay, so start with why. Okay, why are we doing this? Okay, so knitting for dummies. Okay, actually, I'm one of these dummies. These terms are probably not correct, and I hear knitters are actually pretty like serious about the terms that they use. So forgive me if I use the wrong terms. I'm trying to get this from my son. But anyway, general idea is basically you have a pattern of the thing you want to build, like a sock, right? And then you have stitches. There's a unit action, and then you have a sequence of stitches, the steps. So this is this composition thing again, right? So and then you have repetitions of steps. So repetition is actually the key problem here. There are different types of steps. There's a stitch level step, there's a needle level step, and then you have multiple needles as a round if you're doing a sock. And then you can have multi-rounds for a step, and you can even have vague steps like do rounds until you hit 2 inches. Okay, and repetition is really a key. And there's different types of repetitions, and they could be nested. So you kind of repeat this thing, which repeats this thing. Okay, so it's actually kind of complicated. An interesting thing, I did not do this on purpose. My son was actually knitting on the plane, and this is the app he chose. But actually, one of the first applications of computing was actually a loom, the Jacquard loom. Right? For CS people probably know this, right? The automated, basically Jacquard automated weaving fabric and patterns into fabric. Okay? So the user journey here is you have a user a person who wants to knit. Okay, decide what to knit. You find a book or something, or go on the web, or design a pattern yourself, and then you follow the pattern. Right. So you set up the threads, do the stitches, move to a new needle, then you repeat this n times, and you can have nested times. Okay. So the pain points are, and this is for me interviewing. So this is what a product manager would do, interviewing my son. It's easy to lose count of repeated actions or steps, especially if there are nested repeats. Okay. So for steps, and then for steps like knit rounds until you get 2 inches, sometimes you don't know how many rounds that would be. And then when you do the other sock, you have to remember how many rounds you did. Okay, so it was an interesting insight. And then obviously it's inconvenient to carry the knitting book everywhere. And you can get them in PDF now, but it's still kind of pain to kind of scroll it, zoom in, whatever. And it's easy to forget what step you're in, not just the count, but the actual step. Right, and sometimes you put down the sock, and you come back, and you're like, I forget which step I am, and I forget which round in the step, right? Interestingly, he also wants to know like how fast he's knitting, so he can plan his time with, right? So, and there's this thing about whether in the round you stop in the middle, whatever, quite like it's kind of like gets complicated, and then there's like different terms, flat versus round. I'm like, they're just rounds. No, it's a row. But they're just rounds anyway. So there's all these things. So you can already imagine what you might want to build here, right? But there are non-goals. Like if you can't do everything, you don't need it to track per stitch because it's not bothersome anyway, and it's easy enough. And he's okay with like manually entering the instructions because actually people write them in different ways. So even though actually I think this would be a nice application of AI, just give it a picture and then give you the pattern. But that's like later, right? So we're okay with just arbitrary text. So given this, you can already imagine an app. right? So here are the pain points and non-goals, okay? Imagine an app where instead of the book, you put whatever was in the book into a phone, and then the phone will track for you, right? And so taking from the pain points, so again, breaking it down, features that might be useful in this app are some kind of counter because you need to count the repeats, something to remember the steps, something to enter the steps, and then handle the steps at different levels, and then maybe a timer to give you your time estimates, right? Some things that are nice to have, but not in the minimum viable product, okay, are multiple levels of counters with nested repeats, letting the user choose whether it's needle or round, and then reading it from a text file or PDF. You can he's okay with just entering it himself if he has to, for the MVP, right? So there we have a spec, and this is basically the upper part of this, the PRD part, okay? So what's next? Okay, so now we build it, okay? Well, what actually happened next was basically my son did that prompt and then it came up, right? So it came up with the app, he had the prototype, but then he needed to modify it and it became harder. So that's why you have to understand this part so that you don't just let AI just skip that, do it for you, and then you don't know what's going on, right? So let's continue, right? So here we want to define the features, okay? So what features do we want? Oh, I already have this, okay? Now, as an engineer, I want to say, okay, I want this. Can you make this simpler? You're asking for too much, right? What is I know this is the MVP you want. Can there be an even more minimal MVP? And I actually asked my son this, and basically what we came up with was basically this, okay, which is what knitters actually do. I don't know if you guys know. It's a clicker, and you just count, okay. And he said, yeah, this is what I use, right? So, and I said, okay, that's a good MVP, okay. Covers all these points, okay, so at least partially, right? So it helps you count whatever, and yeah, and this is why people use it, right? And it's a simple behavior, right? Your inputs are up, down, reset, shows a number as an output, and then behavior is goes up and down, and it covers some of the pain points partially, okay, and okay, maybe it's not quite an MVP because if you're just going to do this, then he already has a clicker. Right? So what's the point? So it would be really nice to have the steps, the instructions and stuff, and be able to keep track of that. But remember, we build up. So whatever we're going to have, we want a counter there anyway. So if we can build this, then this becomes part of the bigger component of the bigger system, the final thing. So good place to start. Now we have to answer, okay, so let's set that for the MVP right now. What are the components we want to build, okay? And so we want a stitch counter, okay? So what does a stitch counter look like? Okay, so first thing you asked is inputs and outputs, okay? So inputs, you have 3 buttons, up, down, reset, okay? Outputs, you have count, okay? And what kind of data does it deal with? And what's the state? So data is just like what kind of information, so numbers, text, whatever. So in this case, it's a number, it's a button press, 1 or 0 in a way. It's a signal or something. State is the data that the system or the component keeps. Okay, and this matters because it affects like the properties and it affects its behavior. Okay, so if something affects the behavior, if it's something that you do, you have to kind of remember inside the system. That's what I call state. Okay, so in this case, the state is the count, and you have to keep it, right? Because when you put it aside, you want to keep the number there, right? And that was part of the features we wanted. Okay, and then you define, you kind of specify like what are the behaviors that you want. So the behaviors are generally, so this is where the engineering thinking comes in, and this is where it would be like I think it's cool that I see everything and it's like, okay, yeah, that thing works at that. If it gets this input, then it does that. So it's like if this, then that, or on this event, or given this data, it outputs this thing, right? So like in terms of a counter, it's like at the start you reset it, on up you add, you down you subtract, 0 you reset, and if the count is changed, then you update the output. Okay, and then the next question is, okay, this is the thing abstractly, in terms of inputs, outputs, and data and behavior, but what is the actual user interface if you're going to make it an app? Okay, so this is where the designers, the visual designers come in and say, okay, well, let's make buttons here, and then let's make a widget there, okay? And then as engineers, you're like, okay, well, this is great, but how are you going to build this? So to build it, you actually have different components. You have to build different components. So you build like a counter, account manager, and inside account manager you have storage to keep the state, and then you have some logic, right? So and then at this point you have a picture of the system, okay? And if you can give this to, well, like before AI, you would actually give this to yourself or to other engineers, and then they can start building the different parts of it, right? But AI can just do this for you now. So cool thing is if you can answer these questions, then you can build a system even if you don't know how to code, right? So that's the cool thing with AI now. So I'm gonna quickly answer this for you, but basically, we kind of walked through it already, but basically there are two sub-components here, the account manager and the UI, and each of them have these inputs and outputs and behaviors, okay? And the account manager has another subcomponent inside it, which is the storage, persistent storage, okay? So I'm gonna show you later where, okay, well, I'll show you how we use that later. But before we do that, the next step in the system design you need to specify is the what ifs, okay? And it's useful to identify this before you feed it into the AI because it will help the AI as well. So what ifs are basically, I call them what ifs, but basically they're scenarios. And they're important because the scenarios give you your test cases. So thing to think about with test cases is what if? Well, how do you know if it's working, and how do you know, or what are the cases where it might not work? Okay, so, and for this, you kind of think about your system and then you answer these questions. So, the happy path is where there are normal cases, right? But you also have to think about like other cases. So boundary conditions are conditions where you're nearing a transition, like either in the numeric value or like some state transition. Failures are when something's broken. Edge cases sound like boundary conditions, but people use this term to mean basically rare cases that you don't usually think of. And then there's things called race conditions, which is what happens when two things happen at the same time. And for all of these things, you want to make sure that it works, okay? Not just in normal scenarios, but also in all of the things that you can think of normal scenarios. And hopefully it works for the required scenarios and the normal ones. And if it doesn't work, sometimes it's okay as long as you fail gracefully. It doesn't explode, right? So in the case of the counter, the happy path, normal counting, boundary conditions are like when you reach zero, what happens when you reach zero? Well, shouldn't go negative, right? Failure cases might be like if the persistent storage is corrupted. This is actually, my son actually ran into this iPhone app that he was coding. And then edge cases, I can't really think of an edge case here, but maybe you can. Race conditions might be like if you press two buttons at the same time, okay? And generally the rule there is a graceful way of handling it is that the result should be something that you can explain if either A came first, then B, or B came first and then A. But so in this case, if you press plus and minus at the same time, it might blip either up or down, but it should be zero at the end. It shouldn't be 2 or something, right? Because it does make sense. But sometimes that can actually happen if your code is incorrect. So test cases are important, and they're important because you can actually AI can actually help you with it. So AI would actually generate the test for you. Some of them can be automated, and those things that can't be automated, things that where you have to manually try something, it can tell you, how you might want to do it. It can give you steps that you can just manually try, right? And these automated tests are useful because of regression. So when it's useful for when you first write it and then it's correct, then great, it's correct and good. But it's also when somebody makes a change in the future, even if it actually often happens that they make a change here and it breaks something else somewhere else, right? So you want to have these automated tests so that when you're not looking anymore, somebody breaks your code, somebody will know, right? And AI is very good at helping with that. But on your end, I think you should do the non-automatable scenarios manually, and also check whatever test AI comes up with. Because sometimes it'll just come up with tests, and it's exaggerating, but it's basically checking if 1 + 1 = 2, and it's actually check that, right? And it's not checking something else that it should have checked, right? So you should check manually anyway, at least once. And then, given all these, what you end up with is basically put this all together, and you get this the spec. Okay, so now the spec is this document which has your motivations, your features, your motivations, your goals, your non-goals, your features, the components, how they interact with each other, the behaviors, and then the scenarios that you want to test. Okay, and then AI will do this how for you in terms of coding. Okay, but for the doc, you probably would want to basically write the guidelines here. So things could be like, what platforms do you want to build it for? iOS, Android, and are there any kind of things like what APIs do you want to use? What model do you want to use? Any kind of style things that you want the AI to kind of follow, and any steps you want it to do. So you can write that in, and then you have this whole doc. And this is actually stuff that you would do in a company, like people would write these docs all the time. Some of them would be split. Like the system design doc that the engineer would write would have a very kind of brief reference to the motivations, because that should be in the PRD doc, right? But it's still there. So given this, you can then feed it to AI, and then it'll build it for you. Just to make it quick, I'll show you the results, and then we can try to play with it live after. So basically, I did this thing. These things I pasted into a Google Doc. I asked Gemini to clean it up for me because it was like in slide bullets, and it actually did a pretty good thing. Okay. So it has basically the stuff in the bullet is all here, right? And then I had it saved to a Markdown file. Wrong. So I had a. Okay, so is that too small? Anyway, you get the idea. So basically, this is the spec that I just had on that slide. Okay, convert it into Markdown, makes it easier for the AI to read, but it's still the same stuff, features, and I tried to be very brief because I was just trying to do this as a demo. And there's also these project instructions, which I just kind of learned to do recently. Actually, I actually asked Claude to give me instructions to give itself, and I found that you could actually ask it to do this stuff for you. So what I'm actually asking it is to draw the diagrams of the components and stuff after it's built it. And then to also do the design, to draw what it plans to do in terms of implementation, and then compare it with my spec. And you get all these things at the end. Just to show you the final result, this is I should zoom this in. Sorry, I can't zoom in. But so this is Android, iOS, web. So I have one folder here which has all the 3 versions, and they're all driven from this spec. And basically, I ran Claude. Yeah, I just said implement this app according to spec system-design.md, and it ran for like 30-40 minutes, used up my quota and charged me money. But it did it. It did all 3 versions, web, iOS, and Android. And I don't even know how to program in iOS, right? Because I never worked for Apple. But and it produced all these other documents, right? So actually, it's better to see it in Claude. So it produced a whole bunch of documents. It has like and it produced tests that it actually ran by itself. Okay, and then it has the architecture diagram. There's the account manager, the buttons, the storage. Okay, and then it actually maps out how these translate into functions in the code, right? And then how are the different platforms different, right? So you have the components here, and then you have web, iOS, and Android. Okay, and it did this for me. So in some ways, I'm kind of shooting myself in the foot, like saying, like you have to think like an engineer, but actually you don't really have to because Claude will do it for you. But you see, at least have to understand this, right? And it does help that when you guide it, because there's sometimes even when it's a simple problem. In fact, I did this happened to me. Like, give it the simple problem, you run it twice, and it gives you two different solutions, right? And it's like, so it's better to say like, okay, let's fix the spec, right? So that the next time you go, you're not gonna try something else, right? So either you write the spec yourself, or even if you let the AI write it for you, at least you review it and you say, okay, I agree, this is what we want. So this is why it's useful to think like an engineer. And just to show you how this works, so the web one is basically, sorry for the small letters. It's basically, I asked it to build something that you can run locally. So it just built an index.html, and you just run it on your local server, and basically, oops. Okay, here. So this thing is actually reading that index.html that Claude produced, and it's a stitch counter. Okay. So one thing I didn't show you was in the first version of this, when I pressed negative, it actually went negative, right? And it was because I didn't spec it out. I didn't say like stop at 0. But what's interesting thing was I didn't change that spec, but I added the y. I said this is a stitch counter. And it figured out stitch counters don't go negative. And it just added it itself. And it actually added a test for it as well. And the nice thing about this is I can run it on iOS. I can run it on sorry, it's wrong app. Okay, so it created the iOS code for me. And so there's the iOS app. And this is a native iOS app that it built as well. And Android also runs yeah, and there's the Android app. Okay, so basically from the spec I did 3 apps, and I have documents to show for it afterwards, and the and yeah, so basically, with this one spec, right? I was able to get 3 different versions. I got diagrams. This is what I was saying. Like in the previous version of this, it actually came up with a different diagram. So it's useful to like understand it so you can kind of review it yourself and then kind of judge this is good, and then say, okay, freeze it. This is what I want, right? But the nice thing was the previous version actually came up with this sequence diagram, which is cool. I didn't even ask for this. It gave it for me. So AI is pretty cool. And the advantage of being able to think is that you're thinking with the AI as well, and you're able to understand it. It also helps with expressing what you want more clearly, right? So my son's prompt, I guess. Actually, the first one, yeah. If you look at it now and you say like, yeah, we can understand why the AI misunderstood it, right? If you start thinking about like, being clear about the components and the inputs and the outputs, right? And even if the AI does it, you can understand it. You can ask the AI to do diagrams for you. You can ask the AI to do tests for you. But it's nice to understand that and be able to kind of prompt it as well. and it makes it easier to make changes because now you know these diagrams. So you can say, oh, put this component into the bigger knitting app, right? Or replace the display with something, right? And it's just a matter of changing a component instead of trying to tackle the whole problem, right? So yes, okay. So that's my demo. We can kind of demo live if you want after, or we can also do exercise. Yeah, question?
Yeah, I was curious. In your initial diagram, you showed it had persistent memory. So if you close the app and reopen it, does it remember which stitch you left off on? Like for the
are you
iOS
asking,
and,
or are you?
the iOS and Android app?
Yeah.
If you close it
Oh,
and
yeah,
reopen
it does.
it remembers
It
whatever
does, yeah.
you left off on. Okay, cool. Yeah, that was the part that would have been the most challenging, I think, to implement.
Yeah. So and that's why you have to call it out too, right? Although when my son prompted it, it was smart enough to actually do it for him. But and I guess the AI is smart enough to try to understand the whys as well. So it assumes like, oh well, you want to keep track of something. I need persistent storage. But yeah, it's good to do that and to test it as well. I think actually when I did one of these versions where it wasn't persistent. I was like, oh yeah, I missed specking that out. But did you want to see it run again? And okay, so I stop it, and then when you run it again, it should show it. So it's persistent. And well, actually, I was going to say AI tests it for you as well when it can. Although I did have it run into a bug because it was getting messed up with the actual. I messed up the test because I changed the state, whatever. So anyway, if you want to do, if you want to try it out for yourself, okay. So some ideas. I can walk around, maybe help you guys try it out. Try to build a stitch counter yourself from. I guess I can share the slides. You can just paste the stuff and try to see how it builds yourself. Try to build, Joseph's knitting app. I think that basically, if you think about the app, and I can show you diagrams of it later, but basically the answer there is basically you have the pattern input, and then you have the counter, the step tracker, and then the counter, right? The nice thing about thinking about it in terms of components is the pattern input is just text right now, right? We said. But imagine if you just replace that part and have it be an AI component where you just take a picture. The rest of the things don't change, right? And you can just worry about that solving that part, translating from picture to steps. So can you actually do that? It might actually be possible. Now, I kind of, people might be expecting a game, so I thought like, oh, well, a game that we could try, which is still kind of related, is this chopsticks game. Do you guys know chopsticks game? Okay. Basically, okay, this is the knitting app I was talking about, storage, whatever. The chopsticks game is basically this game where kids play this. So you start with two fingers. So it's that's why it's chopsticks. And then I think if you tap, you don't tap your own finger, but if you tap the other person's finger, right, then you add whatever's in your hand to that. So it becomes 2 now. And if they tap you, then now it's 1 plus 2, it becomes 3, right? And you have 2 hands, and you can do this. And you can also move fingers from one hand to another. So if you have 3 and 2, you can kind of move one of them here or something like that, right? And then basically you do this thing, and if you reach 5, then your hand is out, right? And the goal is to get both hands of your opponent out, right? And I thought like, okay, this could be a game. And guess what? If you think about it, engineering-wise, this can use the same component that the stitch counter uses, right? And I'll let you think about how to do that, right? And the thing here is that if you think about the game rules, that's how the behaviors, the inputs and the behaviors play, right? And now you have 4 counters because you have 4 hands. And then you have a UI. How are you going to do the UI? Again, actually, I asked Gemini, like, can you explain chopsticks for me? And it actually made the app for me right there. I didn't even ask it to make that app. It just said, here's an app. Here's a JavaScript demonstration that does this. I was like, I didn't even ask for this, but hey, this is actually fun. So you can cheat and just ask the AI to do it, but you could try an exercise. How would you build this or how would you think about this if you do yourself? Or you can have the AI build it and then ask it to draw the component diagram for you. Okay, so so think in terms of components. Here's the hint, right? Inputs, outputs, what's the data, what's the state, behavior, components. Right? So we can leave you with that, but one final point. Okay, so takeaway here is one, just remember Legos. Okay, be specific, break down, but also build up. And this breaking down and building up is all about thinking in components. And this is the thing I wanted to share. Like I see components everywhere, and actually I just realized this is kind of Ignatian actually, because the finding God in all things. It's like I see components and systems in all things. So just realized that it wasn't on purpose, but and then why, what, and how. Right? If you're going to tackle a problem, want to build something, think about specify why, what, and how. Right? So yeah, I hope I've shared something with you, and I hope you all start seeing systems everywhere like I do too. Okay, thanks. Any questions?
Thank you to Liz for giving a wonderful presentation, and I really think it just shows how you can really get started with building anything you'd like, because the human brain is so creative, and especially when you're going into a field or already in a field of your choice, you're able to take inspiration from the things that you're learning in class and try to find out how to apply it. And so
sorry, I have a question. As a pro user, because for now our account is pro plan. There's a max plan. So for pro user, do you have any suggestion on how we can save token? Because the token is quite limited for pro account.
Yeah, I'm not the pro on this. Actually, I'd love to hear from other people, but I think there are ways to but one is what you don't do is not think in advance in terms of this is why components are useful, right? Because then you become really specific. If you just say, no, that isn't quite right, I wanted this, right? Then you're going to waste a lot of tokens. Like the AI will do something else that you didn't really like. So I think that's one thing. But there are tricks to caching the inputs, and then splitting the outputs, because when things are bigger, then one, they cost more. When the output is bigger, the outputs cost more than inputs, and sometimes it tries to budget, so the quality actually goes down if it tries to fit within the budget. So do it in smaller pieces, basically. Yeah.
I just had one suggestion to add to saving tokens in case anyone runs into. If you start out, it automatically starts out in Opus 4.7, and if you just switch it down to Sonnet 4.6, it helps a lot really fast. But you have to do it at the start of your conversation because you can't switch partway through your conversation.
I also have a question for specifically when you use AI for developing apps too. In the case when you build apps with more complicated structure, like you have a series of navigation steps and you need to coordinate the different UIs and layouts in the process. When chatting with Clara to help you modify ADEs involves with a series of complicated code which is hard to understand. In this case, is it still necessary to master some basics and fundamentals before penetrating into a complicated app system?
You're asking if it's necessary to master how to do engineering before tackling a complicated system?
Yeah, to understand the code.
I guess I don't know what master. I think even just a sense of just the stuff that even if you start thinking the way I'm I've been thinking. That helps a lot, right? So if because you can ask the AI to draw things in diagrams for you. So like if at least for me, I'm very visual. Like I like seeing blocks. Oh, I was going to show you the. Anyway, I think I showed you the diagram, right? So I think I did that. Yeah, this one, right? So like it's like yeah, the code is really complex, right? But if it shows you the diagram and it says like, oh well, this component is this file matches this component and it has these functions. That helps a lot, right? And I don't know if so you don't need to master everything, but it's nice to have at least a high level understanding of being able to kind of drill down and.
Thank you so much.
If no one has any other questions,
I did have one more suggestion if you want to just play around. This is just kind of a toy exam. I'm sure some people are probably already doing this, but like I just thought like, oh, like this idea of like Legos, like, hey, maybe you can make, if you guys are looking for a project to do just for fun, like, can you make a tool that can help like people, like my son, who's like, okay, like go through this process, right? Have them visually define the different components that should go in their app, right? And then have that build from there, right? Visually. Because like I'm already doing something like this, right? But if you can make this a little friendlier, this is still kind of nerdy. This is how I think. But like, can you somehow make this friendlier so that more accessible to people? But basically, produce from here like the thing that you feed to the AI, which then produces. So that's another idea for an exercise again.
awesome. Well, there are so many ideas to get started on, and if you are also interested in working on one of these open source projects we have available on our website, it's a great way to put this how to think like an engineer into action, because the best way to start any new project, regardless of what it is to think about how to make the project. What, like Luis said, what are the inputs, what are the outputs, what you'd like to have on your screen, and more. And so if you have any questions, he'll be walking around to help you all. And if you have any questions about projects, feel free to come up to me. Kind of a little sneak peek into next week, we will be having the CEO of Sprinter Health, who will be coming in and telling you a little bit about how to use AI in your personal life, how to apply to personal projects. And this is also a great way to use some of these concepts that Luis just taught. And so, yeah, let's give him a round of applause once again.
And I'll be around next week as well. And I'm happy to see like the projects that you guys are working on.
And so everyone get started. We'll be here to help you out.